All right, so we're continuing our discussion about strategies for simplifying operations. So when we look at our first problem, we have 9/5 divided by 9 squared, all of that raised to the power of 2. So we want to remember with PEMDAS that I want to resolve anything I can resolve and simplify inside the parentheses first before I go ahead and apply any exponents. So what I'm going to do here is apply my quotient rule, which tells me that 9/5 divided by 9 squared is the same as keeping the base of 9 and subtracting the denominator's exponent from the numerator. So I'm going to get 5 minus 2 is 3. So I get 9 cubed squared. And now I'm going to apply my power to a power rule where I multiply the exponents. So I keep my base of 9, and 3 times 2 is 6. And I could put that in my calculator and get a number, but here I was asked to simplify, not necessarily evaluate or solve. So now I'm going to look at my second problem, and again, I see quite a bit going inside the parentheses. Please go ahead and resolve that information and simplify what's inside the parentheses. So I have 4 times 8, and 4 times 8 is just a number, right? It's 32. And then it's still going to be in the parentheses. And then I've got my base of x. And this is really x to the first. And I've got a product here I'm multiplying. So I'm going to keep my base of x. And then I'm going to add my exponents. 1 plus 4 is 5. And then I'm still going to cube that whole thing. So now I'm going to apply the power of the power rule. And I'm going to get, this is really 32 to the first power. So I'm going to get 32. 1 times 3 is 3, so 32 cubed. And then I'm going to get x, and I'm going to do that 5 times 3 is 15. And then I would go ahead and I would do 32 cubed. I'm not going to bother with that. You can do that on your calculator. We get x to the, so it's 32 cubed, x to the 15th. Again, we have another problem where we have a lot going inside the parentheses. Remember, PEMDAS, always do that first. So I have some numbers here. 3 times 2 is 6. I've got a lot of r's, so I've got all of these r's. I have r squared times r to the 4th times r, which is really r to the 1st. So I'm multiplying these, so use that product rule, and I'm going to add the exponents. 2 plus 4 is 6. 6 plus 1 is 7. And then I want to remember that I have that square outside. So now I'm going to use the power to the power rule. So this is really 6 to the first, so it's really 6 squared. And then I have r, 2 times 7 is 14. And 6 squared I know, so I'm going to do 36 r to the 14. Okay, so I can do that one. Now we're starting to get a little more interesting down in our next set. So again, I want to resolve whatever I can resolve inside the parentheses before I go to my power rule. So I'm noticing that I can't do anything with that 6. There's no other number. Really, it would be 1 up here. It would be 1/6. Now I'm going to resolve my x. So I have my x base, right? So I have x to the first divided by x to the 5th is going to give me x to the -4, because 1 minus 5 is -4. Now I'm going to have to get rid of that negative exponent later, but I'm okay with that for now. Now I'm going to resolve my y's. So this is again really y to the first divided by y squared. It's going to give me y to the -1. And I'm going to square that whole thing. I still have those negatives in there. I could deal with it now, or I could wait till the end. I personally like to wait to the end, but that's me. So my 6 is going to be squared, so that's going to be taken care of down here. 6 squared, because this is really 6 to the first. So when I do the power of the power rule, 1 times 2 is 2. My x base, 2 times -4 is -8. And then my y, 2 times -1 is -2. So now, this is not where I want to be. When I simplify things, I can't leave a negative exponent. So I am going to 6 squared is 36, perfectly fine, but this x to the negative 8, I'm going to push it down into the denominator with x to the 8th, because really what this negative means is I don't want to be multiplying, I want to be dividing. And so I'm going to do that inverse operation, or use the reciprocal is another way to say it. I'm going to do the same with the y to the negative 2. Ends up being going from the numerator to the denominator, really doing the reciprocal. I get y squared, and up here I have left 1. And that is my simplified answer. So we're going to see another one similar to that. And here I have a few more numbers happening. And 4/9 is not a number that I can easily simplify. It doesn't simplify at all, and I really don't want to have any decimals at the moment. So I'm going to leave this 4/9. Then I'm going to resolve my x's. Remember, this is really x to the first. So I get x, 1 minus 3 gives me negative 2. And now I'm going to do my y's. I get y to the 4th divided by y to the 6th is really y. 4 minus 6 is negative 2. And don't let me forget that I'm still squaring everything. So now I'm going to do my powers to a power. This is really 4 to the first power. This is really 9 to the first power. So I get 4 squared. I get 9 squared. I get x. 2 times negative 2 is negative 4. And then for the y, 2 times negative 2 is also negative 4. And I'm going to do a couple things here. 4 squared is 16. 9 squared is 81. And this x to the negative 4 is the same thing as x to the 4th, or 1 over x to the 4th. So I'm doing the reciprocal. And y to the minus 4th is the same as 1 over y to the 4th. And there I have my simplified answer, 16/81. You could write this like this, 16/81. No, actually no. Nope, I was thinking that this was in the numerator, but it's in the denominator, so this actually is our final answer.